Hello and welcome to my first attempt at trying to record the notes. What I'm going to do is go through them just like I would if we were going over them in class. I will go through each of the slides, do all of these examples, and having this as a recording, hopefully you're able to go back and refresh your memory or to slow down or repeat something in case you have questions, especially because this is just the very beginning and of course it's going to be a lot harder later on and you can kind of go at your own pace this way. So our first section is on lines. Nothing new. Lines we've done forever since, Algebra 1. Before that, who knows what you guys learn in middle school. But regardless, you should all know how to do lines. Slope. Slope of a non-vertical line is given by the equation change in y over change in x equals y2 minus y1 over x2 minus x1. Please write those as subscripts and not exponents because that is just strange otherwise. Also, if I make a mistake anywhere in these, please let me know so I can go back and fix it. This is my first time. We'll just see how it goes. A vertical line has no slope. Okay. Or in other words, undefined. Right? And that occurs when our x values are the same of two different points on the line, and when we subtract them, then we get 0, and we cannot divide by 0, thus we get undefined, and the line has no slope. And that is why up here it says the slope of a non-vertical line. And a horizontal line has 0 slope. Parallel lines have slopes that are equal or the same. Perpendicular lines have slopes that are opposite reciprocals. So in other words, if I have two lines that have a slope of 2, then they are parallel. If I have two lines with a slope of 2 and -1/2, then they are perpendicular. In calculus, it's best to think of slope as a rate of change. So how is something changing over time? The slope between 2 points will be referred to as the average rate of change. How are these two things any different? Okay, say I have a curve that looks like this, and I want to know the average rate of change between here and here. Okay, well, what I would do is I could make a secant line that goes through those 2 points, and the slope of that secant line is the same, it's the average rate of change between those 2 points of the curved function. So in other words, if I took all of these infinitely many points between those 2 points on the function, on the curved function, and I average those together, if I could somehow do that, then I would get the slope of this secant line right here, hence the average rate of change. Doesn't mean that that is always how it's changing between those 2 points, but on average, that is how it's changing. Next one, equations of a line. The first equation of a line that you used in algebra was probably slope-intercept form. So slope is m, y-intercept is b, y equals mx plus b. Right? All it has is slope and intercept and then an x and y, so we call it slope-intercept. In calculus, it is usually easier to write the equation of a line in point-slope form. If the point is x1, y1, and the slope is m, then we get y minus y1 equals m times x minus x1. Okay? So point slope form is usually a lot easier because we can just plug it right in and be done with it, but every once in a while it'll tell us the way that you need to write the equation. So for example, if I have write y as a function of x, well then I need to solve it for y, okay? My slope-intercept form is nice because it's already solved for y all by itself. So in order to solve this one, my point-slope form for y, I just need to add my y1 to both sides, so I get y equals m times x minus x1 plus y1. Okay, and of course if they say write it in function notation, you'll have to do the same thing where you have to solve for y, and then it's just equal to f of x, which is the same thing as y. Okay. Just to be aware on the AP exam, if it tells you to write y as a function of x or write it in function notation, you will have to do this. Now, after this step, you can either leave it like this, or you can keep simplifying so that this is in the form mx plus b, so it's really just back into your slope-intercept form. But the problem there is you could possibly make a mistake from going from this to going to this. So therefore, you might as well just leave it in this way. I know it's not quite as pretty, but if you had this correct and then you had your slope-intercept form incorrect afterwards, they have to take off points. Whereas if you had just left it in this way, then you wouldn't, then it would be absolutely fine. So to write an equation of a line, all you need is a point and the slope. And then you can use your point slope form and you're golden. Next, find the equations of the lines passing through the point -3, 4, and also has the following characteristics. So if I have the slope is -3/7, then I can just write it in point slope form. So I have y minus 4 equals m times x plus 3, right? X minus a -3. Why does this go away? I don't know. We'll just stick it over here. Perpendicular to this line, so that means that I need to figure out, that means I need to figure out the slope of this line first. There we go. So therefore I'm going to add 5y to both sides and subtract 10, and I need to actually put this one in slope-intercept form. Divide everything by 5, and I get 2/5 x minus 2 equals y. So that tells me that the slope of this line is 2/5. So the slope of the line that I want is -5/2. And I just think it's nice to copy over what you're using. So now I have my slope is -5/2, and the point is -3, 4. Ignoring all of this other stuff now, right? We just need to work with our new line, and that equation be y minus 4 equals -5/2 times x plus 3. Again, just leaving it in point slope form. Next one, passing through the origin. So the origin and then our original point, -3, 4. So I need a slope, right? I already have 2 points, I just need the slope. So slope is y2 minus y1 over x2 minus x1, which is obviously -4/3. And then I can write the equation on the line. Well, I can do my point slope, in which case I can use the origin, 0, 0, or the original point they gave me, which is -3, 4. Regardless, I'm going to get the exact same thing. So I'm going to plug in 0, 0 because it's easier. And then I'm going to say, oh, well, that was stupid. Why did I even write that? And this is my answer. Okay. If you put in the other point and then you simplified, you would get the exact same thing. Okay, and that makes sense. We could directly go to the slope-intercept form because the origin is on the y-axis, so therefore our y-intercept, of course, is 0, so it's y equals mx plus b, which is 0. Right, no need to say that. Okay, next step, we have parallel to the y-axis. Any line that's parallel to the y-axis, obviously a vertical line, and it's going to be written in the form x equals something. So if I have the point -3, 4, okay, let me just draw a quick picture because sometimes people get confused with, oh my gosh, it's parallel to the y-axis, but I have to write x equals, and it's just confusing. Well, let me just explain it. Right, if I go to the left 3 and then I went up 4, well, who really cares how I went up 4, right? All of these points, I went to the left 3 to get to it, right? I have -3, 0 here. I have -3, 1. I have -3, 1/2, or pi, or whatever we want to say. All of these have an x value of -3, so it obviously makes sense to have our line be x equals -3. Okay? So vertical lines look like x equals a number, horizontal lines look like y equals a number. And the very last thing we have to do is regression analysis. Regression analysis is a process of finding a curve to fit a set of data. The basic process involves plotting the points and finding a function that best fits those points. The curve that you find is called a regression curve. In this example, our curve is going to be linear, but as you're going to see on the calculator, it could be all sorts of different, actually curvy curves, right? Curve is just a general term for any sort of equation that we're graphing. The median price of existing single-family homes has increased consistently during the past few years. However, the data in the table below show that there have been differences in various parts of the country. So we have 5 different years, and we have the median prices for each of those years in two different categories, right? We have the South and we have the West. Part A says find the linear regression equation for home costs in the South. So I'm just looking at the South row right now, and obviously I'm comparing it to the year. So I'm going to put the year in L1 and then South information in L2. And I can already see that I have questions about the West as well, so let's put that in L3. Okay. Also looking at this data, I see that we're missing a 0. We'll just stick that right on there. Instead of putting in 1990 and 2000 for all the years, well, let's simplify that a little bit, okay? Let's just do it the number of years since 1990. So this would just be 9, 10, 11, 12, 13. And I'll call this T for the time instead of using X. And instead of Y, I'll use P for the price. Okay. That's not necessary, but it's a lot easier when you're interpreting things. And it just looks a lot nicer. So find the linear regression equation for home cost in the South. So obviously I'm going to use my calculator. So let me get out of this. Okay. So since I'm doing stats now, I just go to the stat button and then edit. And oh look, I magically have all of the information right in there. So, and of course, instead of L2 and L3, right, I actually put the entire prices in there. You didn't have to do that too, right? You could divide everything by 100 or by 1,000, as long as you tell me later on that you changed it when you define what the variables are. Just really quickly about the calculator. I don't know why I have my little dinosaur, what he's doing, but he is running. So just really quickly, if you ever want to delete what's in the column, right, you just go up to the name of it and then push clear and then push down and then it will all disappear. I'm not going to do it because I like my information that's in there. If you accidentally push delete, it is going to delete the entire column, okay, in which case you will need to go to insert and you can put in the new column. Okay, the name of it, you have to call it L1, L2, L3, L4. Okay? You could give it a different name if you wanted to call it, you know, price. Then you can do that as well. But if you want to be able to recall it under our vars button here, okay, not under vars, under list. All right. So under list, well, we have all of these right here. You don't know what resid is. Take stats for that. Maybe Liz will teach you. So where am I? Okay, so back under stats. Okay, here's all of my information. And I want to find the linear regression equation. So I go back to stat, calc. I want to calculate linear regression, so go down to number 4. Okay, after number 4, number 5, I can see quadratic if I want a parabola. Number 6, cubic. 7 is quartic, so that's to the 4th. Linear, okay, so we have lin reg again as number 8, and all they've done is switch to A and B. So like for number 4, I have my slope is A, for number 8, my slope is B, and the y-intercepts have changed as well. And number 9, right, that's just my logarithmic equation, exponential, power, logistic, and my trig function. So I just want a line, and I can just push enter, and I get this. Okay, notice it comes out very, very nicely. I do not have my diagnostics on, so therefore I'm not getting my r and r squared. Okay, if you want to do that, we don't need to do it at this point, but you can just go to your catalog, go down to D, turn diagnostics on, and you will have your r and r squared. Don't worry about not having it for now. I'm not going to even talk about that today. So I just want to copy over my equation. So I have P equals 5,980 times x, which is t, plus 90,380. Okay. What does the slope of the regression line represent? Well, think about the equation for slope. That's change in y over change in x. Well, in this case, it's change in p over change in t. So it's my change in price over change in time. Well, if that ratio is the coefficient of my t, right, this one right here, the 5,980, I can write that as a fraction, 5,980 over 1, right? So it's increasing because it's positive at a rate of 5,980 per 1 year, okay? So, whoops, I have to write what we're talking about. So median home price is increasing $5,980 per year. Okay. Ooh, can't see it. Right here. Okay. Why did I write it over 1 like this? Well, to show you why it's saying per year for every 1 year as opposed to over years, and then you guys kind of get a little bit confused. So it's like it's over 1. Well, that means that it's per year. That's how much it's increasing. Okay, and then C says find the linear regression equation for home cost in the West. So we're going to do the exact same thing. So go back to here, and we want to calculate linear regression for not L1 and L2, right, which is our default, but for L1 and L3, right? Our year is still in L1, and now West is in L3. So the first one will take on everything in L1 as our X values, and then the second thing it'll take on everything in L3 as our Y values. And push enter. Nice pretty numbers. P equals 21650 T plus, oops, minus. Let's see, does that make sense that we have a negative number? That would mean that in 1990 they would predict it to be a negative amount in the West. Well, sure, that makes sense. If our slope is that high, right, it's increasing at a rate of 21,650, then sure, I'm fine with that. Yeah, I'm good. So, where is the median price increasing more rapidly, in the South or in the West? Oh, I forgot to put my T is number of years since 1990. And I should write that for both. D. Where is it increasing more rapidly? Well, this is referring to our slopes again. Okay. So we already know that our slope for the south is 5,980, and our slope for the west is 21,650, so obviously the west is increasing quicker. West, because the slope is greater. Okay. And be careful, if both of the slopes were negative, then it would say something about in which region is it decreasing more rapidly. Then you're going to look at which number is more negative. So in other words, which one has the absolute value of the number that's greater. But we don't have to worry about that here because they're both positive. And then finally E, using your regression equation in part C, predict the cost of a home in the West in the year 2011. So I'm plugging it into my equation in C. Oh, what is my year? Well, T is not 2011 because we had T equal the number of years since 1990, so I have to say 2011 minus 1990, which is 21. Minus 21,530. Okay, and I could put it in the calculator as it is, or I can have it do all the work for me because I like it when it does that. So if I go back, if I just do second entry, I have linreg for the L1, L3. Oh, that's exactly the equation that I'm using. So comma, I want it to put it in y1. So I just go to vars, yvars, function y1. Okay, so now that it's in y1, right, I don't see anything here, but if I go under y equals, then it's right there, and it makes it so that I can do function notation now. So y1 of 21 plugs 21 into my y1 function, and I get 433,120. 433,120. Okay, and I'm just going to put dollars on there because it obviously needs units because it's a word problem. Okay, and that is our last example. Next up, the slide of all. We have the homework page. On the homework, a lot of times I'm going to give you homework from 2 different sections. This is the quick review, which is at the beginning of 1.1 homework, and then all of these other ones are just the section 1.1 exercises. Okay, so there's only 6 of them down here. I just separated them so that you can do them by topic if you want to. It's not as important now, but once it gets into more difficult material, then, say you understand the first one, well, then you can at least do those questions instead of, and then maybe ask someone else the questions about the other questions some other time. But for homework, I've tried to give you easier examples that you won't have as many problems with, just more basic, straightforward examples, and then we're going to be doing more difficult ones either the next night for homework or in class together. Okay, so good luck on the homework. We'll be talking about this tomorrow, and I hope you got a lot out of this. See you tomorrow.